Hello everyone, welcome back to the lecture. So once we have finished this thing, now we'll try to get into this particular lecture. Okay, I mean this particular image. One more thing you need to understand. See, here there is one thing called as torsion links, right? You can see here torsional links, torsional links. Why this is torsional links? See, when this is also two-leg stirrup only, no. But why it is written torsional links? Can you see one difference here between this ring and this ring? So what is the difference? Here the ring has been bent like this, isn't it? Here the ring has been bent like this. Like you brought a ring that is a two-leg stirrup, and here it has been bent in 135 degree. Whereas here it is not done like that. Here what they have done, no, your bar will be like this. Like here you'll start a bar like this. You'll bring a bar like this. Okay, the same bar will be bent. Then it will be taken like this. Then it will be taken like this. Okay, I mean I'll do it like this. Okay, shall I do it like this? Wait. Then it will be brought up to here. Okay, then it will be brought like this. Then from here it will be brought like this. Understood? No. So this is how these bars are done. Why it has to be done like this? So this is called as torsional links. Torsional links means whenever your beam is subjected to torsion, see, we provide side face reinforcement. So in the side face reinforcement, there is one point which was written. If your depth of the beam is 450 mm, and if it is subject to torsion, in that case, whatever stirrup you are providing, no, you need to provide such kind of stirrup. Okay. So why exactly this has to be provided? Even I don't understand why it has to. Okay, there may be one reason. One reason is because it's see, what is torsion? I'll tell you what is torsion. Give me 1 minute. Yeah. See, if I consider this to be a beam, if this is my beam, so torsion means bending will happen like this. This is bending. Okay, this is normal bending. If I take a beam and if I say bending, the bending will happen like this. Your beam will try to bend like this. Torsion, what happens? This is torsion. So since there is a torsion, what is happening? You see the torsion, it's happening at the surface area. This torsion is happening at the surface area. So because of this torsion, what they have done is they have provided this kind of what is that? Stirrup, or let us say lateral ties. Okay, this is usually provided in the beam. So this is how it is provided. Maybe this particular two support has to be strong. That is the reason they might have done this. Even I exactly don't know why it is like this. But usually for torsion, we can adopt such kind of reinforcement. Only the difference is that in torsion, you have to use only two-leg stirrup. In usually two-leg stirrup, you're supposed to do this. Four-leg will not work out, even though they have written torsion links. Actually, two-leg stirrup. Because what happens? So if this is a beam, if I take this as a beam, if this is a beam, let us say this, because of the torsion, no, because of this torsion force, your torsion force will have this much lever arm. So if you're providing a lateral ties in the outer region, so the more the space, I mean, if you're providing a, wait, let me do it in a better way and leave this. Yeah. If this is a column and if this is a torsion, and if I put a lateral ties here, so lateral ties should be put at a outer face. So since your lateral ties is put at the outer face, it will have a bigger lever arm. So this distance from the center of the torsion, if this is torsion, it will have maximum resistance from here. This lever arm is more. Since the lever arm is more, what will happen? It can resist more torsion. Suppose instead of providing a lateral ties at the outer face, if you provide at the inner face, suppose if I do it at the inner face, let us say you provided one stirrup somewhere like this. So what is happening, you know? Yeah. So what is happening, you know? See, your torsion center is here, and from here to here, this lever arm is very short. Since the lever arm is short, what will happen? No, that resisting moment will reduce. So that is why usually for the torsion, when you're giving a stirrup, you should provide a two-leg stirrup. This four-leg stirrup is not effective. This inner stirrup, whatever you are providing, no, it won't be effective in resisting the torsion. Okay, so that is the main intention actually. But I don't know why it has to be done something like this. That idea I don't have. Actually, you can give it like this only, but this exactly I don't know. Maybe in future, if I get to know that, no, I'll make a separate video on that. Okay, yeah. Now coming back to this type. So this already we know that this is your development length. From here, it has to be LD plus 10 times the diameter of the bar, which we know that. This also we know that wherever you are doing the lapping, there your stirrup spacing should not exceed 150 mm. It is mentioned here, should be less or equal to 150. Even this also we know. Now we'll come to the most interesting part, is this one. So what is this? Here we have two different depth of the beam. That is, this is your depth number one. This is one beam. Okay, this is one beam. This is second beam. This is your second beam. Here, second beam. So here there is a drop. Okay, the top of this beam and top of this beam is different. So there is a drop here. So when you have two different depth of the beam, okay, like top also there is a difference and bottom also there is difference. You see here in the bottom also, this beam is ending here, whereas the depth of the beam is here. Here the top of the beam is here. Here the top of the beam is here. Since there is a variation in the beam depth, whenever you are providing a reinforcement, this is how you are supposed to provide. So how you are supposed to provide, I'll tell you. See the top bar anyhow, wait. The top bar anyhow it will come and you will give a L. This is fine. But and in the same way from here the bottom bar which will come, that will come and you will give a L shape. That is fine. But whatever bar is coming in this bottom portion, no, this bottom portion, this bar should not, wait, I'll go with a different color. Yeah, this bottom bar, whatever you're bringing from this beam, no, you cannot stop it here only. You should extend up to this distance, and this from the this end, from the start of this column to the end of this bar, this one, it should be a tension lap. Tension lap means usually again development length only. Usually it should be 50 times the diameter of the bar. So it should be minimum from here to here. It has to be 50 times the diameter of the bar. Let us consider I'm using a 12 diameter bar. I'm using a 12 dia bar. So what is 50 into 12? 50 into 12 is 600 mm. No, that's it. So this length should be 600 mm. Understood? So these things you are practically supposed to follow it on the side. So from here to here, minimum you have to give 600 mm. Only then that much amount of tension will be generated, and that is how your bar will not slip from here. In the same way, here, the top bar from this particular beam should not be stopped here. It has to extend up to this distance, up to here. Till what distance? Again, same thing. From the face of this particular column till this particular distance, it has to be a tension lamp, which is usually 50 times the diameter of the bar. Understood? This is very important. Whenever you have two different depth of the beam, this is how the connections of the beam reinforcement are to be given. So when you go for the interview, when you have, let us say, 3 to 4 years of experience, when you go for the interview, definitely there is a chance they'll ask you such questions like how do you do this such kind of connection. A fresher is not expected to know this, but when you have 3 to 4 year experience, when you have worked on some high-rise projects and all, you should know how to do this connection. These connections are very important on the site. Okay, fine. Why this has to be done? Because that much amount of tension should be generated. So this much amount of tension is generated only when you give this sufficient development length here. Okay, yeah. In the same way, they have given another detail here. This detail is also similar. Here, this is proper. This bottom will go continuous. But again, this top bar, whatever you are bringing, you can stop it here. From here, the bar, whatever you are bringing, you extend up to this distance. This is your tension lap. So here, the bottom, your beam is same, but the top, there is a difference. There is a drop in your beam. Okay. Now we'll come to one more connection. This is detail 3. So what is the difference between detail 1 and detail 3? Here and here, the detail difference is that here your beam depth is different. Here the beam depth is different. Okay. There is a variation, top and bottom. Whereas the top is same. The top is same. Only the difference is in the bottom. See, this is one beam. Shall I go with a different darker color? Yeah. Yeah. See, this is one depth of the beam, and this is another depth of the beam. Another depth of the beam. Understood? Now, here what is the difference? Top, there is no difference. Top level is same in both the beam. Only the bottom, there is a difference. This depth is bigger and this depth is smaller. Whereas here, even though, let us say the depth may be same, of course, the depth may not be same, even though it's the same, this top level and this top level is different. This bottom level and this bottom level is different. In that case, you're supposed to follow this. Now here we'll see the difference. Here what you're supposed to do, anyhow, top will not have any problem because top bar anyhow, since the depth is equal, top is matching, this bar will go straight. The problem will come only in the bottom reinforcement. This bottom reinforcement you should bring and take it inside the column, whereas the next rebar, whatever you have, no, this rebar. Yeah, this rebar you have to extend sufficient into this particular beam, and this should be your tension lap. This much should be your tension lap. Understood? This is how you're supposed to understand. So this is when you have two different depths, there is a variation, there is a drop. When you have a difference in the bottom level, this is how you're supposed to do. And most of the construction practice, whenever we work in bigger projects and all, you get to see such kind of beams where one beam depth is different. This is a higher depth, this is a smaller depth. So in that case, this bar bottom should be brought and bent and taken here, and from this bar should be extended up to this point. This is very important. Now they have given one more detail for this. I never worked. I never worked on such projects. But anyhow, just try to see that. Again, same thing. Here, what is the difference? Top also there is a drop like this. Bottom there is a drop like this. So in that case, you're supposed to follow this. How you are supposed to follow? Anyhow, top bar you can bring and you can give L like this. Bottom, this top bar, another layer bar, you bring and extend up to here. Then this bar from this side will come and get extend here. Only the difference is that this another bar, whatever you have, no, this bar you should bring like this, and you should give this shape, and then it should be brought here. So I never worked on such project so far in my life, because this usually happens when you're working on a very high-rise building, if it is some complicated structure and all, and if there is a need in the difference in the level of the beam, only you're supposed to follow this. But at least try to have an idea, like whenever there is a difference in the beam level and all, this is a kind of the arrangement you're supposed to do. But this is generally seen. Normal building also you get to see usually this kind of detailing and this kind of detailing. Sufficient. Okay, fine. Other than that, nothing else. This is enough for us. And one more thing they had mentioned here about this thing, side face reinforcement. It is written here. This top bar, bottom bar, 1, 2, 3, 1, 2, 3. This is a side bar. They have written side bars here. Okay. And here they have mentioned the distance between the two bar, whatever you're providing, no, it has to be maximum 250 mm. That generally depends. They'll do the designing. Usually it will be 200 center to center, but he has given in general that it should not go beyond 250. And he also has mentioned one more point. The first side face reinforcement bar, whatever you are providing, no, it should be at the depth of 2/3 of height. Yeah, this also you can take it as a thumb rule. Generally, sometimes in the drawing, they may not give you. So what if let us say you're working on the side. Somebody told you that, Akshay, you're supposed to provide a side face reinforcement. I agreed, okay. But I don't know like where I should start this side face reinforcement. So I can use this as a thumb rule. Whatever is the depth of the beam, take 2/3 of that. For example, let us say my beam depth is 750. Okay, what is 2/3 of 750? 2/3 is 0. Wait, 2/3 is 0.667. I'll multiply this by 750. I'll get to 500. Okay, 2/3 of 750 is 500. That's it. So 500 mm. So I understood one thing, that this distance should be 500 mm. See, all these things you should know. Okay. All these things, even I'm also learning after 6-7 years, because usually you will not get to work on such projects, no, initially in your life. But if you understand all these things, it's always better. See, this distance, this distance should be 500 mm. Okay, 500 mm. That's it. 500 mm means, in other words, if I want to tell, from the top, after 200 mm, you put your first side face reinforcement. Got it? That's it. So this was all about the critical beam detailing. And apart from this, I'll show you one more image. We'll see that also. Quickly, I'll run through this so that you get an idea. I think like I took a few of the drawings from there. Yeah. Quickly, I'll show you one more drawing just for your understanding. Okay. See here. Yeah. This no? Again, this is layer 1, layer 2, layer 3. What is this bar? This is your pin reinforcement or spacer bar. Now he has shown the spacer bar here. And this also, this is layer 1, layer 2, layer 3. This is your side face reinforcement. This is your spacer bar. Okay, that is all understood. Apart from that, what else you are supposed to understand? That's it. Apart from that, nothing else is required. This and all, development length and all, these are your straight bar. These are your side face reinforcement, which you know. Okay. Wait 1 minute. I think there is a merge of two images. Wait. Yeah. So these things, already last time I'd explained you, but still I'm showing it once again, just for our understanding purpose, so that I don't want anything to be missed out. Yeah. So last time we know that this is L/4, all these things, and see, sometime in the drawing, you might see this kind of reinforcement shown. See, what is this reinforcement? So this is your side face reinforcement. Okay. So the side face reinforcement, when you're seeing it from the longitudinal section, it will look like this. General drawing, you don't see such kind of reinforcement. This is a side face reinforcement. Apart from that, what is another learning that we have? Another learning what we have is this, we know that whatever stirrup you are providing here, it should be at the closest spacing, and it should extend up to 2 times the depth of your beam, 2 times the depth of the beam. We already know that. Here there is one more thing which you need to understand. The stirrup spacing, whatever you are providing, no, that should be less or equal to d/4 and 8 times the diameter of the bar in zone 1. But anyhow, it's not required because usually the stirrup will be designed, so you don't have to do this calculation. Just in case if they don't give that the stirrup should be placed at what distance, then you can refer this. Again, I'll repeat, this thing is to be followed when you're doing earthquake resistant structure. Normal structure and all these things are not required. So I'll not make it complicated. What I will do is I've shown it here. Just go through this. If you have any doubt, you get back to me, I'll explain you. So again, unnecessary, I'll not make any explanation here. And if I explain too much, you'll get confused. That is why just go through the drawing. If you feel there is anything which you are not understood, just WhatsApp me with the image. I'll explain this to you. Okay. Unnecessary, I don't want to complicate the things. These things already is understood. No need. Already I've explained you. Apart from that, you see here, they are given typical RC detail. Same, whatever I explained there, same thing I'm showing it here. Typical RC detail for variation in the beam depth. You can see the same thing, no? So there is a variation in the beam depth. This beam depth is small. This beam depth is bigger. So what they did is they have shown it like this. That top bar, and now it will go straight. You don't have to worry. This bottom bar, what you are bringing from here, bring it and give us sufficient development length. That is mentioned here. This will be your development length, which is LD plus 10 times the diameter of the bar. And this bar, whatever you are bringing, no, of course, this I'll bring it like this. And this bar, whatever you are bringing, you have to extend up to this distance. At what distance they are mentioned? From the face of the column, it has to go up to LD. Whatever I explained, they have shown it in one more drawing, general drawing. Apart from that, initially, if you remember, whenever you are bringing your column beam reinforcement into the column, this is typical junction detail of beam to beam connection. If this is your main beam and if this is your secondary beam, you're always supposed to bring the bar of your secondary beam, give a small crank and take it inside the beam. You have to always do this kind of things. Usually on site, they don't practice. If you work on small sites and all, people don't do all these things. But here he has mentioned that this bar, whatever you have now from the secondary beam, you cannot directly take the bar into the main beam. Okay, usually this is how we try to do. If you remember what we usually do, no? If this is my primary beam, my secondary beam reinforcement, I'll bring and rest it here. Here is telling that what you're supposed to do, that is not how you're supposed to do. Bring the bar, give a crank and take it inside like this. Bring a bar, give a small crank like this and take it inside. This is how you're supposed to do the connection with the secondary beam and the main beam. Okay, understood? No, that's it. So just try to understand all these things. See, it will take time. I agree, but you should know all these things. After spending 30-35 hours in my entire course, you should have that kind of knowledge because nobody else on this planet will teach you to this level. That much guarantee I can give you. Nobody has the patience also to teach so many drawings and teach you each and everything. So why I'm teaching is because I don't want anything to be missed. Since you have taken the course, that is the output I'm supposed to give. And I don't want you to miss anything. And if I miss, I know that in future, it's very difficult for you to learn all these things. Nobody is concerned about teaching all these things. So that is why I'm teaching you all these things. Even though it is little extra, but try to understand. If you don't understand it in a single go, watch my video for 2 to 3 times, you'll be able to understand. Okay. Yeah. So that is sufficient. Apart from that, I want to explain one more thing. That is about the simply supported beam detail. This is very important. I'll explain you this also. Maybe in the next lecture, I'll try to explain. Apart from that, there are many other drawings again, which I need to explain. All those things we'll try to cover it in the next lecture. Okay. So I'll see you back in the next lecture. Thank you.